Hi, welcome to Lesson 6A, Number Sequences. We're going to be looking at number sequences over the next few lessons because sequences and patterns are all around us. And so we'll take a look at the number sequences that we will find in this math course. What we're going to need to do is we're going to need to be able to identify or recognize patterns in sequence of numbers. We're going to also need to describe the patterns in words, and we're also going to need to continue the pattern that we have found. Okay, so that's part of the process of what we're going to be going through today. Sequences of numbers are made up of terms, or also called members, which are defined in their position. They have a specific order in the sequence, and they all follow some sort of rule in order to get from one term to the next. Infinite sequences continue on forever, I guess as the name would suggest, and finite sequences will end at some point in time. Let's take a look at a couple examples. So for this example here, we want to write down this description, and we want to also find the next two terms. So take a look at the numbers here. We got 480, 240, 120, and 60. We can look at these and kind of develop what the pattern would be. And what we're going to do then is we need to describe this. So we could say that the sequence starts with 480, and each term after that is produced by dividing the previous term by 2. I really need to learn how to write with this thing. This is ridiculous. Sorry about the writing. So we see that 480 is where it starts. We divide by 2 to get 240. We divide that by 2 to get 120. We again divide that by 2 to get 60. And then the next two terms are 30 and 15. Okay, let's move along here. Describe the given number pattern and write down the next three terms. Well, this one could be a little bit more challenging. So if I take a look at this, I see, okay, well, see in this previous example, we were dividing by 2 in each term. I'll take a look at this term and I think, okay, well, from 2 to 6, I guess we could either add 4 or multiply by 3, okay? Then 6 to 12, we could add 6 or multiply by 4. Then from 12 to 20, we can't really multiply by any integer value. It could get a little messy if we start multiplying by decimals or fractions, especially because the last two we didn't have to. But then by adding, we could say we'd add 8 there. So From term 1 to term 2, I could say that we're adding 4. From term 2 to term 3, we're adding 6. From term 3 to term 4, we're adding 8. So we see that there is a pattern there. And I'm just trying to think, if I'm trying to describe the pattern like I did up here, where I said, well, the sequence starts with 480, and then after that we just divide each by 2. Well, here, for the second example, I would be saying, well, I divide the first term is 2, and then I would add 4, but then to get to the next term after that, I would have to add 6, which is kind of in a pattern. We're adding 2 to the previous difference to get that, and then we're adding 2 to that previous difference to get the next term after that. It seems it's a little kind of clunky. It might be a little challenging to describe. I mean, I guess you could say that each additional term is added the next even number, something like. I mean, it just gets a little bit, I don't know, awkward, I suppose, to word that. So I'm not really a big fan of that. So if it's not that easy as like the previous example, what I'm going to take a look at here is I'm going to take a look at these term numbers here, just to maybe give us a little bit of a hint. So that's term 1. Sometimes the terms can be written as T with a subscript. The book we're using uses U with a subscript. There's term 2. Term 3 is the 12, and term 4 is the 20. Now, one thing, just while writing that down, I took a look and I noticed that the 2, obviously, every first term is going to be divisible by its term number. So 2 is divisible by 1. I see also that 6 is divisible by 2. Interesting. 12 is divisible by 3. 20 is divisible by 4. Okay, so maybe there's something to do with the term number itself. So let's just write this down. So term 1 is 2. Term 2, I know we got it right above there, but I'm just going to write this down here. Term 3 is 12. And term 4 is 20. Now, if I were to divide the term by the term number, obviously that's 2. I'll divide this by 2 to get 3. Divide this by 3 to get 4. And I'm going to divide 20 by 4 to get 5. Notice that the values that result by the division are 1 greater than the term number itself. So maybe we're onto something there. So let's try this. Maybe if I were to write a general term sort of thing, or some sort of description, I would say that each term number could be developed by maybe multiplying the term number by the term number plus 1 more. Maybe that would work. Let's give that a try. So if we take term 1, so n would be 1 in both positions, because n is just 1. So if 1's there and 1's here, then I've got 1 times 2, which gives me the first term. Okay, that works nicely. For term 2, if I were to take 2 here, place the 2 in for n here and here, I get 2 times 3, and that gives me 6. Okay, that's working. Okay, so 2 terms works nicely. Try it for the third one. So I take the 3 for n, and I substitute that in for n here and here. I get 3 times 4. 3 times 4 is 12. Okay, I think things might be working out here. And then I'll take term 4, substitute the 4 in here. 4 times 5 is 20. Okay, that seems to work. So I'm going to say then that this is now my description for this number pattern, that the number pattern is the term number multiplied the term number plus 1. And the next three terms would be, well, if this is term 4, I'm multiplying 4 times 5 to get 20. So term 5 would be 5 times 6 to get 30. And then I get 6 times 7, which would be 42. And then 7 times 8 gives me 56. And if I were to follow along with this addition pattern here, plus 4, plus 6, plus 8, we see that this next jump is plus 10. Then we've got plus 12. And then plus 14. So it seems to work out quite nicely along both avenues there. Okay, so that would be a little description of number sequences. I'll catch up to you in a couple seconds when I move on to 6b, which is the general term of number sequences.